ordinary triangle, what I'm going to do first of all is to label the vertices of this triangle. I'll find them. Angle A, angle B, and angle C. Okay, so we have our triangle. We've labelled the vertices A, B, and C. So using this information, we can name this triangle. So this triangle has now become triangle ABC, and we can use our little triangle with the letters A, B, C to actually represent that. Okay, so this particular triangle is triangle ABC. So if you have a look up here on the board, I've said that triangles can be named using the vertex labels. So this one here is triangle ABC. We've got A, B, C. This one here is triangle DEF. So we can say it is triangle DEF. So I could change the one on the floor to be triangle DEF by removing the labels A, B, and C and giving it the new labels D, E, and F. It's now become triangle DEF, and we can call it that, we can name it, we can label it, we can write it as triangle DEF. Okay, there we go, we have triangle DEF. Okay, so this particular triangle, we've been naming it using the letters, the vertice letters. Okay, we can also classify this triangle. So, we can classify this particular triangle by its length of its sides. So if I pick up each of the sides, we can actually see that 1, 2, 3, we've got 3 sides, and you can see here that each of these sides is the same length. Okay, so because I've got these 3 sides that are the same length, okay, I'm going to remove the labels. So I've got my 3 equal sides, which means I have an equilateral triangle. Okay? So, an equilateral triangle. This is an equilateral triangle. Okay? Now, the other thing about an equilateral triangle is that the angles are the same size. So, if the angles are the same size, they have to be 60 degrees each. So this one is 60 degrees, this one is 60 degrees, and this one is 60 degrees. So we have three angles for our triangle. Each angle is 60 degrees. We can check that with our protractor. If we get our protractor here, we can see that the angle here is 60 degrees. We can see that the angle here is 60 degrees. And we can see that the angle here is also 60 degrees. Okay? So this is our equilateral triangle. We have 3 equal sides and 3 equal angles. In particular, they are 60 degrees each. Okay, I could change my triangle, and this time I'm going to keep 2 sides the same length, but I'm going to change the length of the other side. Okay? Now, I'm actually going to change it by changing the length of this, putting it here, and then using the same length sides for the two top sides. Okay, we now have an isosceles triangle. With our isosceles triangles, this side and this side are the same length. This side is a different length. Okay, this one is a different length. Okay, now because these two sides are the same length, and the next one is a different size, when we use our protractor and we measure our angles, what we can see is this angle here is approximately 75 degrees. And this angle here is also 75 degrees. So these two bottom angles are equal. This top angle is 40 degrees. So we have two angles the same length, same size, and one angle that is different. This is an isosceles triangle. Stay there, boys. I'm recording. So we have two angles the same length, same size, and one angle different. Sorry about the interruption. Okay, so we have our isosceles triangle with two lengths the same length and two angles the same size. So, as you can see here, isosceles triangle, two equal sides, two equal angles. We show the sides as being equal with the two marks on them. It could be 2 marks, it could be 1 mark. The point is it's the same on this one as it is on this one. We have two angles that are the same. We show that by showing which angle we're talking about, and we've shown a dot in each angle to show that they're the same size. Okay, our last triangle is a scalene triangle. Okay, the way I'm going to do this one is I'm going to put these two sides away, and now I'm going to have 3 different length sides. So you can see here the black side is shorter, the yellow side is next size, and the red one is quite long. Okay, so give me a moment, I'll set up our triangle. One side. Oh, it's not very easy to see the black on the floor. Sorry. I'll remember that for next time. But you can now see I've got 3 different length sides for this triangle. Okay? When we have 3 different length sides, we call it a scalene triangle. When we have 3 different length sides, we also have 3 different sized angles. So that's this one here, the scalene, 3 different sides and 3 different angles. So we've spent that bit of time classifying our triangles by their side lengths. So this is by the side lengths. Okay? So the next thing we're going to think about is triangles are also classified by the size of their interior angles. Interior angles mean the angles that are on the inside. So, I'm going to remove the black side, and I'm going to use my yellow again, and I'm going to make a triangle like so. In this particular triangle, I don't care about the size and the length of the sides. What I want to know this time is the size of the angles. Now, I'm not going to use my protractor because I only need to know if they are bigger than, smaller than, or the same size as a right angle. Okay, so we should remember, if we've got a piece of scrap paper, we can make a right angle very easily. To make a right angle, we take our piece of paper and we fold it. It doesn't matter where we fold it, but when we fold it, we get a nice straight line. A straight line being 180 degrees. When we fold it again along that straight line, we now have a 90-degree angle, okay? So that 90-degree angle is going to help us to decide whether or not the angles in this triangle are bigger than or smaller than 90 degrees. Okay, so if we have a look here, we should hopefully find that each angle is smaller than 90 degrees. If they're smaller than 90 degrees, then we have what we call an acute triangle, because each of the angles is acute. This is an acute triangle. So all angles are acute, which means they're less than 90 degrees. We have an acute triangle. So we can classify this angle, this triangle, as acute. Okay? Right. Now, the next one is going to be our right angle triangle. I'm going to use the floor to help me with this. So I'm going to lay one side of my triangle along the grid floor here. I'm going to lay the other side of my triangle up the grid on the floor, and there we have our right angle. We can check it. There we can see it's a right angle. And then I need my other side length. I'm not sure this is going to be long enough. What I might do is shift it down a little bit on one side. Okay, there you go. If I fold that under, there we have our next triangle. Now this triangle has a 90-degree angle in the corner here. We show that with the little square that we place in the corner, and here we can show that it's 90 degrees. So this is our right angle triangle. So the little square in the corner, and we call it a right triangle. There's two acute size angles in this particular case, and one 90-degree angle. In fact, it would always have two acute angles and one 90-degree angle. So, here we go, our right triangle. The last one is an obtuse angled triangle. Okay, to do that, what I'm going to do is I'm going to make my angle bigger than 90 degrees. So here we have, I'm going to use this side. I've now made it bigger than 90 degrees. I'll remove my things that tell me that it's 90 degrees. I'll bring this around to here. It's much easier when you guys are helping me with this. But there you go. Now I have one angle that is smaller than 90 degrees, another angle that is smaller than 90 degrees, and one angle which is much bigger than 90 degrees. So because I've got an angle that's bigger than 90 degrees, this is an obtuse angle. Because we have one obtuse angle, this is an obtuse triangle. Okay, so here we have one obtuse angle, which makes it larger than 90 but less than 180. We have an obtuse triangle.